Alright, today we're going to talk about multiplying matrices. We talked about adding them and subtracting them and multiplying them by a scalar, but we have not talked about multiplying them. Alright, so in order to multiply them, there's a couple of things we got to know. For example, this little chart right here is important. You want to get this down. You have the dimensions of what you're multiplying. So first matrix is called A, the second one is called B, and it has dimensions like 2 by 3 or something like that. And as long as the two inside numbers are equal, you can actually multiply. And if you can multiply, the new matrix is going to be the outer terms. The dimensions of the new product whenever you multiply is going to be this. And so basically in English it says the product of two matrices is defined provided the number of columns A is equal to the number of rows. So the number of columns is equal to the rows. So row by column. Alright. If A, it says if A is an M by N and B is an M by P, then the product is M by P. So basically the point is, as long as the rows and the columns are the same here in the middle, you show them that they're multiplied, then the outer dimensions are going to be the new dimensions, okay? So if they're not equal, you cannot multiply. So this is the part you need to have down. All right? Now, how do we actually multiply them? Once we figure out that we can, how do we actually multiply them? Here's a key concept as defined in the book that I like to use. And so you need to get this down as well. Alright, so you might want to pause this so that you can actually see how to do it. The basic way that you're going to multiply A times B. Notice that you got A and you got B and AB. If they're written like this, that means they're being multiplied. See how the letters are right next to each other? That always denotes multiplication. You take your top row in the first matrix and you multiply them by the first column in your second matrix. But the way it works is first element times first element, then you add it to second element times second element. But that's that first one in that position right there. Then this row times this column. But it's A times F plus B times H. Then bottom. This row by this column. Row by column. And you're adding the individual elements. And I'll show you that here in a second. Let's go back up here to this just to get an understanding of what this is trying to say here. Alright, let's suppose you have a 2 by 3 and a 3 by 4 matrix that you are multiplying. Notice that these two numbers are the same. If that happens, or when that happens, that allows you, now you have the freedom to multiply these two matrices that I don't have up here, but hypothetically. The new matrix is going to be a 2 by 4 matrix. How do I know that? Because I take those two outside numbers whenever I do this, and I know that my new matrix is going to be a 2 by 4 matrix. So these give me the freedom to actually multiply, because if they're not the same, I can't multiply them. And then 2 by 4 is going to be the new matrix. Here's an example. Find AB. Remember, if they're written right next to each other, that means multiply. A is this, B is that, so I already wrote it. So let's actually go through and multiply. Alright, so the way you would multiply is, first of all, let's check. 2 by 2, and this is 2 by 2. So if both of them are 2 by 2, then those two are the same, and I'm going to get a 2 by 2 product at the end. So let's look at what I have here. What you would say is 1 times 5 is 5. Plus 4 times 9. What's 4 times 9? 36. That's the first number right there. The second number is going to come from this row and this column right here. So 1 times negative 7 is negative 7. And 4 times 6 is 24. So you have to add first times first, second times second. So it's row to column. Now down here, I'm no longer messing with 1 and 4, it's 3 and negative 2. So 3 times 5 is 15 plus negative 2 times 9 is negative 18. And then 3 and 2, negative 2 times this column, 3 times negative 7 is negative 21 plus negative 2 times 6 is negative 12. Okay? Now, so again, row times column. Row times column gave me those two. Row times column. Row times column gave me these two. But how do you actually do it? Well, you take the first element times the first element and you multiply them. The second element times the second element and you multiply them, but you add those two products together. First element times first element, second element times second element, and then you multiply those, then you add those two together. So this now becomes 41 and 17 and negative 3 and negative 33. That's the product. Okay, do you know how 2 times 3 is 6 and 3 times 2 is 6? I think that's called the commutative property. I forget. But that doesn't really work with matrices. Matrices, they have a little something different. The order in which you multiply is very important. And so I just want to show to you that I'm using the same A and B here. If I flipped it around, then I won't get the same answer. Let's prove it. Row times column. 5 times 1 is 5. Plus negative 7 times 3 is negative 21. Then 5 times 4 is 20. Plus negative 7 times negative 2 is 14. 9 times 1 is 9. Plus 6 times 3 is 18. And 9 times 4 is 36. And 6 times negative 2 is negative 12. And so you can see that when I add these together, I'm going to get negative 16, 34, was that 27, and 24. You can see here that these are not the same. So AB does not equal BA. So flipping them around doesn't work when it comes to matrices. The order matters. Very important to understand that the order matters. The order matters. This is something else that is good. These are some properties that we should know already, but it may be good to have it as a reference. So you might want to pause this and copy this down. It's just something that I wanted you to see. Alright, let's try this. When you multiply and you have different types of matrices. Alright, so let's check and see if we can actually multiply these first. This is a 2 by 3, 2 by 3, and this is a 3 by 2, 3 by 2. So you see how the two middle are the same, so we can multiply those, and that means my outcome is going to be a 2 by 2. 2 by 2. Alright, so let's go through with it. And the reason that is because now I got 3 here to multiply by 3 here. If I had 3 here to multiply by 2, 3 in a row, 3 elements, I guess, in a row, and 2 elements in a column, it wouldn't work. So it has to be, those numbers have to match. Alright, here we go. So we're going to multiply, and 1 times 9 is 9. 3 times 4 is 12. 0 times negative 2 is 0. All right. Same thing with this column. 1 times 1 is 1. 3 times negative 3 is negative 9. And 0 times 4 is 0. So what did I do? I multiplied all three of these by these two, but I added each one of their products together. That's how you multiply. Let's do it again with the bottom now. 2 times 9 is 18. 2 times 4 is 8. Excuse me. That is incorrect. I should have did 12 times 4, which is 48. Excuse me. Negative 4 times negative 2 is 8. Alright? And then 2 times 1 is 2. 12 times 3 is negative 36. And negative 4 times times 4 is 16. Okay, now we gotta make that negative 16, by the way, because that's negative 4 times 4. So that's plus negative 16. Alright, so what does this equal? 9 plus 12 is 21. 1 plus negative 9 is negative 8. What is this? 56 plus 18. 74 and negative 52. Was that negative 50? Yep. Okay, that is your answer there. So this is how you would multiply if they don't have the same dimensions. Alright? So this is multiplying matrix. And your mama joke for the day, your mama so fat that when she fell, no one was laughing but the ground was cracking up. Ah! I'm not sure what just happened there, but back to the notes. This is multiplying matrices. These are the examples. And there were some things for you to write down. If you have any questions, let me know. Remember, the order does matter in which you multiply. And you have to make sure that you actually can. You just can't multiply everything. You have to check to see if it's multiply worthy. Ta-da!